This is exercise F.1, exporting stream geometry from ORD into a HEC-RAS model. In this exercise, we will add the applicable stream survey geometry and cross-sections into ORD and then export the data that can be used in a HEC-RAS model. So let's start off by creating a new file. Then we're going to name this file road-to-HEC-stream model. And we're going to use a t.c2d seed file. And we want to save this file in the appendix folder, appendix F. So road-to-HEC-stream model as a 2D seed file in the appendix F folder. Go ahead and press save and let it open up the created file. So once your file loads, let's make sure that the default view is active in the lower left corner. We also need to attach a few files. So we need to attach the alignments, the survey, and the terrain file. All still within that appendix F, and all by using the coincident world attachment method. Fit view, we'll see all of the data here. Next, let's select the terrain boundary to open its properties. Then under the reference section here, the override symbol, just go ahead and turn that to yes. So by double clicking or opening the drop down menu. So now we can kind of change up what we want to look at. So then under the calculated feature display header, change the major and minor contours to on. And let's confirm that the triangles are off. So our file should be looking like this. So on the right side of this alignment, there should be a blue circle, and that's where we want to be working with. And since it's a little choppy, I'm going to go ahead and turn off the minor contours. So on the right side of the alignment, we see the blue circle. This is the stream we're going to be working with. This is the existing box culvert on the eastern side of the project. The survey reference file provides maps, survey elements for the project area, including the stream center line for Pumpkin Creek branch, the bank extents, end walls, and the pipe culvert invert elevations. So we got the stream center line and then the bank extents. Now let's review the survey data along the stream and locate the existing 77-foot long 10-foot by 5-foot box culvert within the dashed blue circle. Let's follow that stream center line upstream in the southwest direction and locate the existing 64-foot, 22.5-foot by 4-foot arch culvert. Continue to follow the stream center line upstream to the end of the survey data and locate the existing 483-foot, 10-foot by 8-foot slab culvert that crosses through the interchange. So next we need to trace the stream center line for Pumpkin Creek. Select the existing stream line element template, which is under Survey, Drainage, Natural, and Existing. Now that we have the attribute selected, we go ahead and open the Place Smart Line tool under Open Nose Modeling, Drawing, and Placement. And we're going to change up some of the settings here. We're going to leave it as lines. We're going to change this vertex to rounded and the radius as 0.05. And we're going to leave all of these checked. So starting on the north side of the roadway at the downstream end of the Pumpkin Creek, which is around station 700 plus 00, trace a smart line along the stream center line to the upstream end of the interchange ramp, which is around station 712 plus 85.73. So now I've traced the entire stream centerline all the way down. Now we can set the chain start station to 700 plus 00. Once the start station is set, we can turn off the Road to HEC Survey DGN reference to view the stream centerline. Now we need to draw in the left and the right banks of the stream. So let's turn that survey file back on. Let's select the existing bank line top element template under Survey, Drainage, Natural, and Existing. Existing bank line top. And note that the provided survey for this project has already defined the stream banks. Bank lines will not always be defined in the survey file. It may require a designer to draw in the bank lines either by using the direct offset of the centerline or by using the individual survey points. The left bank line, LBL, and the right bank line, RBL, are established from the stream centerline facing downstream. For this exercise, the LBL will be on the left or the northwest, and the RBL will be on the right or the southeast. So let's go ahead and open up that Place Smart Line tool once again, and then let's set some settings. So this time we want to just change that vertex to be sharp. And then we'll leave everything else as it is. So let's trace that LBL from the survey starting at the downstream side of Pumpkin Creek, going towards the upstream side. So whenever there is a break in the survey bank line, connect the bank line to where it reappears to maintain the continuous line. So we're doing LBL first, which is the one on top or the one on the northwest side. So once we have the LBL traced in, we can go ahead and do the right side. So the RBL, which is again is on the southeast side. So next we need to draw in the left overbank line, LOB, and the right overbank line, ROB, using a 35-foot offset from the LBL and the RBL. So now using the same existing bank line top element template, let's change the line color to 11 or purple. You can select any line style attributes for this exercise, however, the specific color was chosen to provide a visual difference between each of the features. So now we can open the Move Parallel tool under Open Rows Modeling, Drawing, and Manipulate. And then we can set up some of these settings. So we want this first one, we want miter, we want the distance to be 35. We want to use active attributes, and we want to make a copy. So now we can just go ahead and select that line we just drew. I'm going to do the LBL first. And then just left click out to the left of that line. And it's going to automatically offset it by 35 feet. And then right click. And same thing with the right side. I'm just going to click that right RBL line. Go to the right and it should automatically place it. So left click once and then right click. And now we have our two outside lines. And we can go ahead and turn off that survey file. So now we need to draw the cross-section lines along the stream. So let's turn on the Road 2 survey reference file. Let's select the existing cross-section line element template under Survey, Drainage, Natural, and Existing. So existing cross-section line. Let's change that line color to 8 or green. Once again, you can select any line style attribute here, but we're just going to choose this color for this part of the exercise so it's a little bit easier to see. So let's open that Place Smart Line tool once again, and we're going to leave all of this like it is. Line sharp and these three checked. So we're going to first draw some cross-section lines to the downstream end of Pumpkin Branch, so around station 700, so on the far right. So let's place the first vertex on the northwest side of the stream center line, the second vertex directly on the stream center line, and the third vertex on the southeast side of the center line. Note that these cross sections are drawn from left to right, looking downstream along the stream center line. Also, the number of cross-section vertices can vary at each cross-section line. Vertices should be added as necessary to ensure the cross-section line is perpendicular at the contour outside bank lines and perpendicular to the stream center line within the banks. And also note, do not place bounding cross-sections near the survey limits or culvert openings. The terrain in these areas may vary in accuracy due to the terrain triangle connection in these challenging areas. And for the remaining cross-section lines, go ahead and first trace the 4 provided in the survey reference file. Like the downstream cross-section line, trace the northwest to southeast direction. I recommend to draw at least 2 cross-section lines on both the downstream and upstream sides of culverts. Since some of the cross-section lines have already been traced from the survey, we need to add 1 additional cross-section line at each of the box culverts and arch culverts. Add vertices as necessary when drawing the cross-section lines. So these don't have to be anything exact. I'm just going to add one here. Next, we need to draw a cross-section line just downstream of the slab culvert and the upstream end of the Pumpkin Creek. Finally, drawing the last cross-section line about equal distance between the cross-section lines just drawn and the next survey cross-section lines downstream. Again, add in vertices as necessary. Again, your cross-section stations do not need to match up exactly to what I have and was in the manual, just kind of rough estimates. The stationing will vary depending on when and where the smart line was drawn. So let's go ahead and turn off the survey DGN file. So we should have 11 cross-section lines visible. The manual does list out some of the station ranges that you could place these. As long as you kind of got them in the ballpark of where I have them, you should be good. And again, the cross-section stations, you don't need to match exactly. Stationing will vary depending on how the smart lines were drawn. Also, if the bank over bank lines do not extend beyond the cross-section lines at the beginning and end stream, HEC-RAS will not be able to recognize these cross-section lines once exported. So open up the extend line tool if necessary and extend the bank and the overbank lines beyond the cross-section lines. We'll now export the stream model into a format that can be opened in HEC-RAS software. So let's open the Create HEC-RAS Data tool on OpenRoads Modeling, Terrain, and then Analysis. So under this hydraulic, open the drop-down menu and it should be Create HEC-RAS Data. Notice the first prompt is locate the first section line. Select the first cross-section line on the downstream end of the Pumpkin Creek, so the north side of the roadway. And then ask us for the next section line. So let's go ahead and just select each of these cross-section lines going in the upstream direction, and then right-click at the end. So I have all 11 of them clicked. I'm going to right click to complete that. And then the next prompt is to select terrain. The terrain should have been previously been set to active. So right click to use active terrain. If yours wasn't, you can go ahead and just select the terrain boundary as well. And then next prompt is to locate the reference line. So let's go ahead and select that stream center line. Next is to locate the left bank over. So select the left over bank line, which is the one way out here. And then left bank, so just the LBL. And then right bank. And then right bank over. So a Create HEC-RAS Data window should appear. For this exercise, browse to your Documents folder and create a new subfolder called HEC-RAS. Save the road to HEC streammodel.geo file in this location. I already have one in here, so I'm just going to go create mine as 2 and then press save. And now it should be in that location. And this export would then be used in HEC-RAS. Since this manual does not cover HEC-RAS modeling, go ahead and close RD. This concludes Appendix F, Exercise F.1, exporting stream geometry from ORD into a HEC-RAS model.